Have you ever considered the potential influence of clouds, those billowy formations in the sky, on the shaping of our planet's future? It might sound like a riddle, but it's a pressing concern for climate scientists worldwide. You see, clouds play a pivotal role in the global water cycle, which includes processes like evaporation, condensation, and the transportation of water. But there's a twist in the tale. Enter Timothy Palmer, a climate physicist from Oxford University, who's sounding the alarm about the behavior of clouds in the face of global warming. He's concerned about the uncertainty surrounding these natural phenomena, as they are one of the least understood elements in our climate models. What's more, they could either dampen the effects of global warming, buying us some time, or amplify them, sending us spiraling towards a disaster. Clouds, as it turns out, are not just pretty to look at. They could very well be the game changers in our fight against climate change. Clouds, in the context of global warming, present us with two broad possibilities. Picture this. On one hand, clouds could be our unexpected saviors, acting as a natural thermostat of sorts. Their ability to reflect sunlight back into space could essentially dampen the effects of global warming, buying us a bit more time. This is what we refer to as negative feedback. But there's another, more concerning scenario. What if clouds decide to play the villain in our climate story? Instead of dampening, they could amplify the effects of global warming, behaving more like a blanket, trapping heat and accelerating the temperature rise, a process we call positive feedback. This scenario could push us, as climate physicist Timothy Palmer puts it, on the road to disaster. So, are we heading towards salvation or disaster? The answer, my friends, is still up in the clouds. You might be asking, why is it so difficult to predict the behavior of clouds? Well, to answer that, we need to dive into the world of cloud physics. Clouds are complex entities. They're formed from water droplets or ice particles, and their behavior is influenced by a myriad of factors, including temperature, humidity, and atmospheric pressure. Now imagine trying to understand how these variables interact with each other, and then trying to incorporate this into a climate model. It's like trying to solve a puzzle with countless pieces. Moreover, our current knowledge about how clouds interact with temperatures is quite limited. We can't fully grasp these interactions yet, which makes it challenging to accurately integrate them into our models. But why does this matter? Well, these models are what we use to predict future climate scenarios. If the models are off, our predictions will be too. Understanding clouds is no walk in the park, but it's a challenge that we must meet head-on. Recent model calculations have given us some alarming insights. The latest studies, including those from the Coupled Model Intercomparison Project, have shed new light on cloud physics, particularly on the nature of individual droplets. By comparing these findings with weather prediction models, a disconcerting conclusion emerges. Clouds are likely to amplify, not dampen, the effects of global warming. Our understanding of how clouds interact with temperature is still limited, but these new findings suggest a shift in our predictions. Rather than acting as a buffer, giving us more time to address climate change, clouds might be hastening us towards a disastrous scenario. The role of clouds in our climate is complex and multifaceted. They are crucial for the global water cycle, influencing evaporation, condensation, and the transport of water. But this new evidence suggests that they might also be a significant player in accelerating global warming. The stakes are high, and clouds, it seems, are not on our side. So, where do we go from here? The answer lies not in the stars, but in the clouds. There's a need, a real urgency, for more research on clouds. We're standing at a crossroads, and the path we choose to tread will shape not just our lives, but potentially the future of our planet. Our understanding of clouds, their behavior, their interaction with temperatures, is still in its infancy. Yet, they have the potential to either alleviate or exacerbate the effects of global warming. It's a double-edged sword, and we need to know which side we're dealing with. We need accurate data, comprehensive studies, and meticulous comparisons. We need to delve into the microphysics of clouds, into the nature of individual droplets. This is not a task for tomorrow, but for today. Our future might just depend on something as tiny as droplets in a cloud. It's time we looked up and took notice.